Okay, let's get started. So today we're going to finish assignment number 1 and start assignment number 2. And before I start, I want you to take note. I don't know if anyone has downloaded the assignments yet, but I just refreshed them and put them into the LMS maybe yesterday. So the order has switched around a little bit, and the assignments have actually switched around a little bit. So I'm sure nobody has worked that far ahead yet, but for those of you have? Oh, no. So for those of you who haven't, which is probably majority of the class, you want to go into bhacker.com and you'll see, in fact, I'll just bring it up right now. If you go in, you'll see the new assignments that are posted for this term. I realize that I have to keep switching them around, otherwise I get recycled assignments. So these are different than the assignments that were up here for the last course. They are also, I moved this up a little bit, so you see the link here. I'll make this a little bit bigger so we can see it. So the weekly videos, or the daily videos I should say, are going to be in this link. The course materials link, the only thing that has changed is the order and 2 of the assignments. And I'll be going over all of them as we go through the course. But if you have downloaded them already, download them again, is what I'm saying. They are also in the LMS, and you can also start uploading into the LMS or EMS. That if you go to ems.itu.edu, this is for the benefit of the new people in the class. Your interface will look slightly different than mine, but if you go into courses, access the course, this is object-oriented programming with Java, and if you go into assignments, there'll be a link on your end, or there might be a slightly different interface for you to upload assignments. So I would encourage you, as we get them done, just to go ahead and start uploading, because this 8 weeks will be done very soon, yes? If you don't have an EMS account, don't worry about it. You can still wait for a few. But I would contact... Okay. It's okay. You can wait, as long as it doesn't take up until July 4th. Which is, if they do it within a month, we'll be in good shape. So you can just save them up, and then when you get the access, go ahead and post them when you have everything ready. Yeah, but don't worry right now if you don't have it. Alright, so let me refresh your memory. We were working previously on assignment number 1, and assignment number 1 was the temperature. In the temperature class, let me just kind of review what I did last time, just in case you weren't here. And also kind of gets us all on the same page as well. I'm trying to make this as big as possible. We were making a class called temperature. The temperature had 2 data members that were associated with it. One was the temperature, you know, the degrees, and the other one was whether it was in Celsius and whether it was in Fahrenheit, which is the scale. You want to call it scale. So in doing that, we first created, and what you're looking at right now is the temperature class. And we had 2 private data members. We had one a float value. Actually, you know, I realized you can probably make value an integer if you wanted to. You don't really have to make it a float. I mean, unless you want to keep track of partial temperatures. Usually someone says it's 70 degrees, it's 71 degrees, 72. No one ever says it's 71.5. So we could have made it an integer, but it's no big deal. And then the scale, which has got to be a character. It's going to be an F or a C. And I noticed something in here. I have really, you know, I could have used a method, I guess, to convert everything to upper. But I'm not doing any error checking in here either, so I'm assuming everything's in uppercase. So, you know, because a lowercase c and an uppercase c is going to be 2 different c's, essentially. They're 2 different characters. But we're assuming that, and you can make this assumption as well, that, you know, you're only allowed to enter uppercase or lowercase or something, but be consistent so that you can set things correctly. So we're writing the temperature class, and these are the 2 fields I just mentioned. And the first part, which is what we did last Monday, was to create the constructors, which we did. We had 4 constructors, and I left it to you to implement the bodies of some of them. And what I did is I just put some notes in here, actually. We have default constructor number 1. And default constructor number 1, notice no return type on any one of these constructors. Constructors have the same name as the class. They can take on any number of parameters, but they don't have a return type. And another thing to note as well is the one that is empty is referred to as the default constructor. And that one will go off automatically if no other constructor is created when we start looking at inheritance. So we want to put a default constructor in there. According to our instructions, the default constructor was supposed to set the Celsius to, I think the degrees to Celsius, perhaps. Oh, here it is here. If no specified Celsius, if no scale is specified, and the other one was to set it to 0, so set the degrees to Celsius with 0. So, which is kind of the default. So this is what it looks like. Here the value would be equal to 0, the scale would be equal to C. Most people got that part from Monday. And the other part here, I kind of filled it in for you. So I'm not going to give you the code. You actually even have to download the video or copy it as I'm talking to you. It would be way too easy for me just to give it to you, because you know what people would do is they just turn around and give it back to me. It's like, that's not fair. So. Alright, so this was constructor number 2, and constructor number 2 took on a value V, constructor number 3 took on S for scale, and I called it S and I called it V, and I was actually just talking to a student right before class started, and he said, well, can you call it value? And I said, oh yeah, I could call it value. The only problem is there's going to be a little confusion between, is it this value or that value? And if you do that, then you're going to have to preface this value, like this value is this value. So if you did this as an example, here I'll just do this right here so you can kind of sort of see what I'm talking about. You're going to get a little, I have to change that value, you're going to get a little warning usually, and the warning is going to say, well, the assignment to a variable value has no effect because you're taking value and you're having an equal value, and it assumes it's this value. So if you do this, you're saying, well, this object's value, which is now this one up here, this is the value we're talking about. But that's a lot of work if you think about it. So, in fact, it's kind of confusing as well. So if you just say, you know, value or V or VE or something, then it's a little clearer. So it's just a matter of preference. There's a lot of things in programming that's just a matter of practice or preference. So I just thought I'd point that out. The other thing that you saw from the lecture notes, hopefully, and I covered this on Monday just to review, was the fact that this in here is calling this constructor explicitly, which is going to set value to 0 and scale to C. It's always the first line of the other constructor. Why is it the first line? Because it's going to set it first, and then the second constructor is going to run second, which means this is going to call this constructor first. It's going to set temperature to 0, value to 0 and scale to C. And then this one's going to go, and this one's going to set value to V. So what happens to scale? So you're going to have, and if you left out this, scale is going to be left unknown, and it's going to cause a problem further down the road. So you could put this in here, and this is going to set whichever one wasn't set, because it's going to automatically be initialized first, and then the second constructor runs second. And so we would have scale actually set to C in this particular case automatically for us. And I'm doing this with all of the constructors, so you can see value in here as well. This in here as well. For my second one that's setting the scale, I didn't put it in this one because I don't need it. This one's taking on both of the parameters and setting everything for me automatically. If I had other stuff, and I sort of went through that kind of drill on Monday, and I took it out because it was kind of, yeah?
Instead of using this constructor, can you manually enter the value with scale is equal to C?
You could, but it's a lot of redundancy. It's, again, another programming option. Instead of putting this in here, she was asking, well, can we just put, you know, value is equal to 0? Sure, you can do that. That's okay. So, but you know, it's more classic to see this, just because then you can change it in one spot. It changes it for everything. What if you want the default value to be -1 instead of 0? Then you got to change it in all those constructors. You could change it just one spot right here if you wanted to. Plus, when we start looking at inheritance in the second part of this lecture, you're going to say, whoa, wait a minute, that constructor runs, and then that constructor runs, and then that constructor runs. Uh-oh. And then if this constructor is running and it's not setting the values correctly because you left them out because you did them all manually down here, you might have some weird side effects, some, you know, odd behavior that occurs. So it's safer to put this in here instead. Just makes it more consistent, safer. I don't know. So yeah, now we have constructor number 4 down here, which has got both values. I could have some values that aren't in any of the constructors that I can put in the default if I wanted to. What you don't want to do is this up here. A lot of the students, you know, they try to do this instead, which is okay, you know, theoretically. But you're not allowing these values, what if they don't ever get changed? You're not allowing for any debugging in the long run or anything. So it's you don't want to declare, but you don't want to initialize. You want to use the constructors to initialize. Because when you start looking at, let's say, Android platform and stuff, if you don't follow that rule correctly, you can get kind of in a weird situation where it's never initialized. So because you put it in the wrong spot or something. Alright, so we got that far on Monday. We also looked at the modifiers. I call them modifiers and accessors, the sets and the gets. You'll be happy to know if you're going to take the Objective-C course coming up after this series. Objective-C actually has that feature built in, so you can actually create automatic setters and getters. In Java, you have to create them yourself, and so it's really common to see them created together in groups. So you see set value, set scale, get scale, which I sort of put in here already. So I kind of tried to put some labels on here for the accessors and the modifiers. You don't really have to call them anything. You can call them setters and getters, which is what they call them in Objective-C, actually, setters and getters. And you say, well, so if you ever read stuff and it says, well, automatic setters and getters, that's what it's talking about. It's going to do the stuff for you. Because we know why you have to write a method to return the value. And I'm going to show you actually in a few minutes that these values here, the setters and getters, work all over the place. They can work inside of this class implementation, and then they can work in the driver program as well. So they're kind of user-friendly that way. Alright, so I believe this is as far as we got actually. And I said, well, I was going to show you the temperature stuff and the comparison stuff and the conversion stuff today. So that's what we're going to finish up with. So back in our instructions here, we had the setters and we had the getters, and then we also needed to create, and this is, I didn't go over this on Monday, so I'll do it now, two methods to return the temperature. One to return the degrees in Celsius, the other one to return it in Fahrenheit. So we're going to use two of the following formulas here to convert. And I decided, and this is actually just an implementation technique, you don't have to do it this way, but I decided to implement it inside of the temperature class. Because that's where you want it. You'll kind of see it done outside. It's really bad practice. Because remember what I said before, temperature should be like totally contained. Everything having to do with the concept of a temperature should be inside of the temperature. So you could do it in the main driver program. But then every time you write a new driver program, you have to repeat that functionality if you want to convert from Fahrenheit to Celsius. So in concept, it really does belong inside of the temperature class. So here's our two methods to return the temperature. One to return the degrees in Celsius, the other one to return it in Fahrenheit. So we're going to use these two formulas here. And I just cut and pasted the formulas verbatim. I did have to add this little asterisk in here, however, because there's no direct, this doesn't actually work. When I retype the assignment, I'll probably just put the asterisk in there if I use it again. Just because I know some people will try doing it this way and they'll get an error message. But you have to put the asterisk in for multiplication. It doesn't work on its own. There's nothing really too trivial on here. The only thing that's kind of interesting is the use of the return and, again, the check on the scale. So this is basically, getting you up to speed on basic programming. So the purpose of this is to see, well, can we do a comparison? And here we did an if, the scale, and we use a double equals. If we do an equal, we're doing an assignment. So for those people who are brand new to programming, this is your syntax for a control structure for the if. You can also do if, but it's more common to do an else if. And just to reiterate the point, if does a check. This check in here, this scale is equal to C, which is checking. I had to put a capital C in there. If I put a small c in there and it's a capital C, then we're going to end up with a, it's going to come out false because it's a small, not a big C. So you could do a conversion, but I don't know. I'm sort of assuming that everything's going to be in caps. This will always evaluate to true or false, which is why in Java, actually, it's kind of the same syntax in C or C++ and other programming languages. Actually, same thing in Objective-C. You put it inside of two opening and closing, brackets, because you're emphasizing the point that this is true, this is false. I could separate this out and just put the word true in there. It would actually work just fine too. If true, then it would work all the time. So there's no check. But the idea is to, is it true, is it false? And then we're going to do a return, and the return is actually instead of doing the calculation, I could make a temporary variable and say, well, float temp is going to be equal to this, and then return float temp or something. More common to see it this way, actually. It's fewer lines of code, a little bit easier. And then we have our else if on our scale. We could have just said, I could have just said else and left it alone, actually, because if it's not C, it's supposed to be F, right? But what if it's not neither one of them? Then I could do another one, you know, else if it's neither one of them, or just an else on the end here. So my level of error checking is not really that sophisticated, long story short. But, you know, as you develop more programming skills, you'll probably want to, and this is not good practice, you'll probably want to make it a little bit more error prone, or less error prone. So the formula is the same, actually, to get the Fahrenheit or get the temperature in Celsius. And I'm using it out here, actually, in the driver program. So if I double-click on the driver program, I'll explain the top in a few minutes. But where I've added these, did I actually run these? I did run them right here. So what I did here is I said temp here in Celsius is, and I took number 4 that I created. Where's number 4? Here's number 4. I created number 4, and I created it using this constructor here. Remember from last time, I created 1, 2, 3, 4. I just added some stuff more to this code so I didn't have to type in front of you. But here we have temperature 4 is going to be equal to the new temperature 70 F. So I'm using one of my constructors, the last constructor actually. And I'm system out, and I'm printing it out. And another student actually asked an interesting question as well. The plus in this case is used for concatenation. So, and if you concatenate this with a string, it'll always equate to a string. You can also run print system out print and print line and all the other variations of print with just a number in there, and it will print the number out. And then, as I was mentioning before, this is polymorphic behavior, where we'll take a number, an integer, a float, and print it out as if it were a string. It can handle multiple different types of data on the input. In this particular case, I wanted to kind of say, well, this is temperature, and so I'm running this get temp in C and get temp in F. And it's a method that's inside of temperature, so temperature knows about it. So I'm running it from temperature, from the instance of the temperature, and I ran it as an instance variable. Didn't actually have to do it that way. I can do it just like the next one I'm going to show you, that takes two temperatures and compares them. And this is the significant part of the exercise, to actually kind of compare and contrast. And I'll show you the way that the method works first, because I happen to be here in the driver program. The next part of the assignment says you want to compare. So you want to create a method that compares two temperatures. And it should come out and tell you, well, let's see, we'll just read it so I make sure I get it correct here. Let's see, it's in here somewhere. Oh, here it is right here. So that was the conversion from Celsius to Fahrenheit and back and forth. Now we have to create a method that compares. So we have a comparison method with two parameters. The two parameters, both of the two parameters are objects of the temperature class. So we're going to create a method and we're going to send two objects to it. And maybe different scales. One might be in Celsius, one might be in Fahrenheit. And we need to compare them, and we need to return, 0 if they're equal, they're same temperature. 1 if the first one's higher than the second, -1 if the first one is lower than the second. I really don't care how you do your scale or how you do your feedback. I've done a slight variation of it actually, but this was probably the most interesting part of this exercise. And let me show you how that actually works. From the driver program, if you think about the logic for a few minutes, you could have one instance of an object that takes on, these are the variations I was telling you about. There's an easy one that doesn't require a static method, but static methods aren't difficult. And this is sort of reinforces the concept in a few minutes here, but you could have one instance of an object, let's say temperature 1, that took temperature 2 and tested it to see if temperature 1 was higher or lower or the same as temperature 2. If you did that, you'd probably create an instance method. So what you'd end up having is the same thing as we had before with convert to Celsius from Fahrenheit. If we look at this code here, the method, and I didn't put it in here, but the method would take, and it would still have to take an object. And it would take the object on the command line, temperature is the object type, and it would take it in and would go, in this particular case, we're calling the object A, and this is the right way of doing it, I should say, and this is the comparison, taking two objects as parameters, A and B, I called them. But we could write a method here that wasn't static, that was just an instance method that took an object. We can send an object to another object, no problem. And that object essentially just compared. It just said a.getScale, a.getValue, and is it higher or lower than this? So we would go this.value, this.scale. And if anyone would like to see, I could probably write it right now if you wanted to, but it hopefully can sort of conceptualize the difference. We're doing this because it's the current instance of the current object, and we're taking another object that we've passed to this instance, to this method, and we're comparing that object's value and that object's scales with our object, or this object value and scale. And we can just do a simple comparison that way. And then we can avoid having to do a static method. But why do that? When you think about the concept, this lends itself quite well to what's called a static or a class level method, because we're really running it on the class object. And the point of this exercise was to sort of show you what the use of this is. So if you notice the keyword static, as the notes here actually indicate, we add static in here. Static, and I'll just put that other method in here so you can sort of see what I'm talking about. Public integer compare, I'll call it compare1, and this one will just take on a temperature A. I really don't have to take 1 if you think about it, because we're going to use this in here. And temperature A will have public static, temperature, opening and closing, temperature A. Well, we can see that this is essentially, I have to do a return in here, hold on. I'll get rid of the error because I don't like looking at error messages. Return 0, how's that? Because it's an integer. It actually doesn't, well, it could return nothing if we wanted to, but essentially what we're going to do, if we did this, we would take an instance of an object out here, and go back out to the driver program, what did I call it? Compare1. Okay. If I did that, and if I had created this instance here, temperature 4, which is an instance, I could go 4.compare1 and put in another one of these instances I created, let's say 1. And what would end up happening is 1, this object 1, and it's an instance of an object because I created it up here, further up in the code, would be passed to this method that's of this instance of 4. So if I did this and I went 2, say 2, I would be comparing 2 compare 1 with 4, as an example. And it would be running from the 2's method, the 2's instance object, that object that was created, that was called 2, which is a different object. And it would be comparing 2 with 4. You could do it this way, no problem at all. But then you have to know, well, which instance are you starting with, and then which instance are you comparing it with? The other more universal kind of way of doing it is to create what's called a class level method. And the class level method is what's demonstrated down here. And the key word here is that we're using the class name temperature. So temperature is not an instance. It's not 1, 2, 3, or 4, which are my instance names that I created. It's the class. So from the class, I'm running compare. And I'm running compare with 1 and 2, 2 and 3, 3 and 4. I just sent a couple instances. It's a universal method that's going to be used on all instances of all classes to return the values to all instances of all classes. That was just why they call it a class method. I can also have class variables, data members, that are class level. All I have to do is put the keyword static in front of it. If I do that, then I can run it from the class level. Why do I want to do that? Well, then I don't have to worry about all these instances. I don't have to worry about 4 being compared to 1 and 2 being compared to 4. Kind of trivial in this particular instance, but This is a little bit more standard. So back here, I've got, in fact, we'll just, I'll print some stuff out to the screen so you can kind of see what this other method looks like. This one here is an instance. It's called an instance method. This one here is a class method. And it's giving you the access level. It's accessed from class, it's accessed from instances of classes. If I were to do this, I would have two values. I would have, as an example here, I would have this. So if I systemed out as an example, I'm not going to put the comparison code in there. It's a little too much work for me right now. So system out print line this dot value. It's going to print out my value, because I'm an instance, and when I'm running this method, I'm an instance. I have a this. Or I can say, well, we have another value. We have this guy that came in. And if I were to do that, then I would go system.out.println a.value. And now I have two different values that I'm printing out. And I can do any comparison I want between the two values. Or, you know, basically the functionality would be the same as this method here. And this method here takes temperature A and temperature B, instances of two objects, from a static method. We called it static, so it's from a class level. It just means that the scope is outside of the object. It works with all objects. And so it's taking A dot, and this is an interesting concept here. Get scale. Everybody's got get scale. If A is an instance of temperature, it has a get scale. If B is an instance of temperature, it also has a get scale. So we're actually taking from this class method and running instance methods. Because up here I have get scale. Up here returns the scale. So if I use get scale down here instead of scale, I would essentially be just fine. If I actually took and said, well, I don't want to use scale in here. I want to use value, and I want to use scale up here. These guys up here are private. You're going to run into a problem. They're private. They're inside of the class instance. They're only known inside of the class instance. They're not known inside of static methods outside of the class. So if you're going to use a static method, you must use static data inside of the static method if you're going to access the data directly. You'll probably never run into a situation, but you never know. If that's the case, you get an error, make this static. And all you do is you add the keyword static up here. But then it turns it into a class level variable instead of an instance level variable. And in this particular case, we're accessing instance level variables. And in order to access level variables, we have to access it through public methods. So back up here, we've got the public method, public character get scale, which is why I'm using the method. So some of you might try it, and you'll probably put in, scale in here, just like I did up here. This will work, because this is all instance. This is not going to give us any error at all. Down here, if I don't get scale, get value, and use those public methods, and if I mix and match instance with class level variables, I'm going to end it with all sorts of different weird kind of syntax errors and stuff that's going to come out of that, because they're private. So most people come up here and make this all public. And then, yeah, it'll fix your problem. Only problem is, you're kind of not really using the best methods. You're just kind of fixing it just to make it compile, but you're not really enforcing anything in terms of the best practices. Alright, you can look at this and kind of go, okay, what is all this stuff here? I'm just doing a simple comparison. I'm using the AND. So it's relational algebra. So I'm saying, if A.getScale is equal to C, and I'm using double equals for comparison. Otherwise, I'm going to end up doing an assignment on it, which I don't want to do. You can do an assignment in here, actually, and it always comes out true, because it's always going to return true if the values are, unless you get type mismatch error or something, and then your value is going to be false. And that's going to cause you problems. So if the scale is this one, what I did is I just took the scales and I said, well, if the scales are the same, compare the values of the temperatures. Okay, well, and then if one value is less than the other, then this or that. And then here we go. If the scales are both F's, scales are both C's. This is a hacked way of doing it. Okay, the first one's a C, the second one's an F, the first one's an F, the second one's a C. you probably could come up with a more, I don't know, easier way of doing this. I just kind of did this because it's kind of simple. But and then it shows you all the get scales and the get temperature. And in here you might notice we're getting the temperature F, and we're comparing. So down here the interesting part is not only are we using the setters and the getters, we're also reusing, and this is the only place where we have to actually use it, we're using the conversion methods that you had to create. The get temperature in the F and the get temperature in the C that takes, if it's a Fahrenheit, converts to a Celsius temperature, and back and forth. So we're using those methods inside of this method as well. We can use any method we want because they're all public methods. So it works just fine inside of the static method. So, if anyone, well, no, I can't really give you this code because then it defeats the purpose of doing the assignment. However, if you download the video in here, I'll just stop scrolling for a minute here and just let it sit. If you download the video, you can just pause it, and I'll scroll through all the code here. So you can pause it, and you can write it all down if you want. But hopefully you'll do it on your own. Just use this as I can't get it to work properly. So let me get the top of the code there too. Okay, we got the top of the code. So, all right, so that's actually the end of the assignment. On the driver end of it, what I did is I added this last little piece here. And the last little piece was kind of interesting. The way I originally designed it is not taking on command line parameters. It's not taking on command line prompts at all. In fact, I'm just making them hard setting it. And you can do this way. It's just perfectly fine. I'm not going to criticize. You're not going to get any points taken off if you do it the same way I just did it. Okay, but if you wanted to follow the instructions down here, because it's the first program for the course, it also is kind of orient you to the concept of the command line parameters, which was also in the last lecture I gave you. So in the driver program, there's two ways of running it. And this program actually works in both ways, but it doesn't do anything with the functionality. It just kind of stops short. And what this does is design the driver program to run as a program. So if you don't put in any parameters at all, it will just go ahead and do its thing. Or if you put in parameters, it'll compile and it'll run with this kind of setup here where you're putting in a number and you're putting it, I don't have it parsing it, I just have it going Java space driver 1 and 2, you know, just two numbers to put in. Takes the two numbers, parses it out, puts it in an array, and it basically just shows you the array, a part of main. And then you can take that and it's a string. It's automatically converted to a string from a character. And then you can take that and convert it to a number or use it as a number if you wanted to as well. So let me show you that code as well. So here's the code up here, and this is why we have this in here. If we're not going to do anything with command line parameters, we could actually take that out. We don't need that in there. Main doesn't have to have anything. In fact, in here, main is void. It's not even returning anything either. Some people like to put the word void in there as well. Depends on your compiler. You might get some issues with that. So the array that we're looking at is called arguments. Arguments comes in, and first thing I'm going to do is check and say, you know, arguments.length, does it equal 0? Which means, and .length is a method. Everything in Java is an object. So we can run methods on all these objects. And we can convert, and I'll show you that in a few minutes, objects to different object types, depending upon what we're looking at. And we see that when we'll see that with inheritance, as it comes up soon. But in here, I'm just checking the length. If there's no parameters, I'm going to print something out that says no command line parameters were entered. And then if there were parameters, else, then we're going to take and use this as an array. We're going to take, well, the first element, which is 0 of the array. And if you're not familiar with arrays, get yourself one of those Deedle and Deedle books, How to Program in Java, and take a look at the array concept. It's just nothing more than multiple values all stored under one name with indexes. And the indexes start with 0. And so here, and you just sort of have to just take this format for what it's worth and just say, well, it's brackets. And so we have an index value 0, index value 1, which is what's coming in automatically. And you just have to take this for granted too. It just is automatic functionality that's built in. You don't have to call it args. You can call it anything you want. My arguments or something. You can rename it if you want to. But it's common to see it called args. So, and templates and stuff show it as args, but it doesn't have to be called that. It's just a variable. It's just a parameter that's coming in. Anyway, long story short, in here I'm just printing out this is argument 1, this is argument 2, and argument 1 is a string. Argument 2 is a string, so I said string argument 1 is equal to whatever this one is, and then this is equal to whatever that one is. And the automatic assignment takes it from this character, number, whatever it is, and converts it over to a string just from the assignment. So you can actually do this. It's actually kind of interesting. Strings will take and create, if the object is of a string type, it will convert whatever you give it to the string and print it out, which is the same thing we're actually doing over here. These are strings that are parameters inside of system.out, and the string is automatically generated by the system, which is essentially built-in functionality for you. So you might say this is a little bit polymorphic if you think about it, and the string object actually comes in handy for a lot of different things. It's a built-in data type in Java, not so in C or C++, but it's built into Java automatically, so it's a primitive data type is what I'm trying to say. Alright, so if I run this program at this, let me zoom out so you can see the output. And for those of you who are cheating, this is the full version. I'll zoom it in so you can see it if you're looking at the video. This is the full driver program. And the full driver program is doing nothing more than, it's one class called driver. You can call it main if you want. You can leave this part out if you want as well. It's just taking in the 2 command line arguments. You can leave this part out as well. I didn't actually use it. Oh, I used it right here, but you don't have to. You can just send it a value if you wanted to. And especially if you made it into integers, send it an integer instead of a float, which makes more sense now that I think about it. Just making some instances, one using each one of the constructors, and then you're exercising. In fact, when I do this, I'm exercising all of them, because those get temps, excuse me, the compare is what I meant to say. Compare is using everything, actually. It's exercising all of those methods I created. Because it's doing the conversion, and it's also doing the get value and the get Celsius and stuff like that, or get temp. Alright, so let me run the sucker so you can kind of see what it looks like, and then I'll run it from a DOS prompt to show you how to do that as well. If you're brand new to Java, you probably have not done that yet. So let's see, let me click on the Java project. Oops, there we go. And I'm going to use the menu item here and just do a run. And what I'm going to see is the output hidden on the bottom. And when I ran it, if your console, I scrolled it down to make it smaller a few minutes ago, but I got no command line arguments were entered, obviously. I've got just the output here. I have, it looks like I'm doing a temperature in C, temperature in F. I took number 4, I believe, and which was set for 70. So this is technically 21.1111. I think the formula is correct, actually. If your formula is not correct, I think that is correct, actually, but don't worry about it. Your grade is not based upon your math skills. It is upon your creation of the method that's using it. And it's returning here for the comparison. Both are C. I had that print out. You don't have to have that print out. And the first one was lower than the second, and the first one is higher than the second from both times. So I ran the compare with 1 and 2 and 3 and 4 when I ran it. So now here's an interesting thing, is we've seen it inside of Eclipse, and we're familiar with that. And we're like, okay, this is great. Let's get it out of Eclipse. See it sort of work at a command prompt. And that's how we're going to be able to test this part of it. Otherwise, you can't run it, with how you're going to send parameters to it. There's probably a way of doing it in Eclipse, but the better way of doing it is just to go out to a DOS prompt. I'm going to a terminal prompt because I'm on a MacBook, but when you go to a DOS prompt, you'll see the same thing. I'll make this a little bit bigger. I believe I have a subdirectory called workspace, so I'm going to change directory to workspace. And lo and behold, I do, which is good. That was sort of a guess. And I believe I called it JP assignment number 1. So I'm going to change the directory to JP assignment 1. This is basically how I'm going to find the files that I need to run. So if I list it out, I have 2 directories. I have a bin directory and a source directory. And you might notice that that's actually all I have up here. I have a source directory here, and actually don't even have a bin directory in here. But I do have a source directory, which is good. The bin directory is the one I'm interested in because that's the one that's going to have the executables. And if I go back here and I take a look, where am I? Here we go. Change directory to bin. I see I have 2 classes in here. I have driver.class and temperature.class. And on day number 1, I did this. I did Java temp. temperature dot, or Java temperature, and I came back and I said, oh, look at that, no such method main. Oh, wow, error message. And they said, oh, you have to create a Java program, you have to create a main program, a driver program. So we did. We created one, and it was called driver.class. So now if I type in Java space driver, and I'm going to give it 2 command line parameters. I'm going to give it 1 and 2. I'm just going to give it some text. Can you see that? Just didn't want to go too fast here. Now the program's going to run. And so instead of saying no command line parameters were given, it's going to say this is 1 and 2. So if I ran it again, let's say for example, and take out the 1 and 2, it's going to say no command line parameters were entered. This is the output I actually got inside of Eclipse when I ran it a few minutes ago. So you might be thinking, well, what happened here? Well, main driver is a separate class, so we have 2 files. So in the old days, if you're familiar with traditional style C programming, you had like, myprogram.exe. No exe, no my program. But there are actually third-party utilities that allow you to create executables. Not such a good idea. It makes them run slower, actually. But here it's actually kind of interesting. I can make this into an icon. This is the program. This is driver.class. This is the program that's running. It's using temperature.class, and it needs temperature.class. So if I uploaded this to a website or something, or moved it to location, I'd actually have to take both of those 2 classes. And if that were the case, I'd create a jar out of it, and I'll go through that later. But or compress them together inside of something. If you look at the document, if you look at the directories for your Java, you'll see a bunch of jars. In fact, if you go into Eclipse, you'll see the jars in here actually. And the jars are essentially compressed. Here we got classes.jar, UI.jar. These are compressed versions, so all of the different .class files are all put into one. And it's easier abstraction-wise. And you just run the jar. You access everything from the jar by running the driver, or by running whatever program is actually going to initiate that. So back here, I'm not going to worry about it because I only have 2 files. I'm not going to do that. But you might, for an example, in the next lecture, I'm going to show you we're going to have multiple classes. And the classes are going to extend upon multiple classes. So what ends up happening is I got temperature here. And what I'm going to do to my nice, beautiful program that's all finished, and the next is I'm going to extend temperature and make another class out of it, make a better temperature out of it. And I'll show you how the temperature actually extends the behavior and grows a repository of classes. So eventually, I'm going to have an entire directory of these .classes, and I can have this guy here, I can call it driver, I can call it my program number 1, my program number 2, my program number 3. And they're all programs that are going to use multiple different classes. Maybe program number 2 is going to use this class from program number 1. It doesn't matter. There's only one version of temperature.class that hangs around forever. And I can add on more classes to it. And so this is basically the reuse feature of Java. Because now that I have temperature, anytime that I want to use a temperature, I've got it. So a lot of people do this with things like date and time and invoice and a whole bunch of commonly reusable kind of components or objects. And once you create the object, it's there. And you just make a new instance of that object, or you extend the object. And you use it and you make a better temperature. You make a better something else. So let me close this and start in. And before I start, are there any questions or anything? Close this for a second. I'll leave Eclipse open because I'm going to start in with creating some new things from that. So that was assignment number 1, believe it or not. It was the whole thing. So you could turn it in. Assignment number 2, because I'm here, I'll preview it for you. And then that way you can start thinking ahead, actually. Assignment number 2, you might notice, is fewer instructions on it. So left it wide open for you. But the instructions that do exist, and this is the one I'm going to start building today. Oops. Get bigger. Here we go. The objective is to practice creating and working with classes and derivations. So what's a derivation? Well, it's a class built from a class. And this is our first exposure to inheritance. And inheritance is super easy, actually. And this is how we get, because we can create classes at one level at this point. We can have a temperature class, a date class, any class we want we can create and use it. And we can have multiple instances of different classes in our driver program. We just tell the driver to create a new this or a new that or whatever. Where we get functionality and we grow the system is through derivation. Derivation is something more than inheritance, another word for inheriting. And what is inheritance doing? Well, Java calls it extending. Extend one class from another class means you get two objects instead of one. So if I extended and I created another class, I called it my better temperature. All my better temperatures also include a temperature. So as far as you go through the inheritance, you've got all of the different subcomponents or sub-objects reinvented for you in each new object that you create. So it extends, it really does grow your functionality kind of quickly, extends things out. So what are we going to do in this assignment? We're going to create dinosaurs. So we'll have a base dinosaur, and the dinosaur will have a species name, a height, a weight, a movement. Those are your data members. So I don't have to tell you anymore, but those are data members. And you're going to have some behaviors. Well, those are going to be the member functions. The behaviors are going to be eating, moving, sleeping. And you have to kind of think out of the box. You know, you're making a you're making a Java dinosaur out of this. You know, the dinosaurs really exist in Java? Probably not, but you know, they are for this assignment. Once we create the basic concept of the dinosaur, then maybe I'll just do this as a separate assignment. That way I can grow it instead of messing with temperatures. But I can show you something with temperatures first. But once we have the dinosaur class, then we're going to make three different types of dinosaurs. We're going to create I can't pronounce these, but Asasaurus, a Testosaurus, a Hadrosaurus, whatever, Osasaurus, fill in the blanks, A, T, and a P, that are going to be specialized. So the concept of inheritance is you start with a base concept, like a dinosaur, and then you make special dinosaurs, you know, ones that eat meat, ones that eat vegetarians, ones that... Huh?
Herbivores, carnivores.
Yeah, ones that maybe run faster, ones that don't sleep, ones that can fly spaceships or something, or ones that can program in Java for you. And then that's where you can actually kind of see the power of the inheritance in terms of the structure. So for each class, you're going to come up with at least 2 additional pieces of information. So you're going to add data members to these classes. And as an example here, you might add different number of teeth or something like that. You might, or add teeth, maybe add a nose, add a tail, add wings, I don't know. Make your dinosaurs kind of special that way. Customize at least one of the sleeping, the eating, the moving behaviors. So that requires you to take existing functionality, use it, overwrite it, or overload it. And that's what I'm going to talk about in this next lecture when I pull up some PowerPoints for you. You've got different options. You don't have to take and just do one thing with this inheritance. You're growing it. So once you have your 3 dinosaurs plus your base dinosaur created, then you're going to create a small driver program and do what you want with it, essentially. So the requirements for this particular program are not quite as detailed as the first one, but gives you the freedom, academic freedom, to kind of do what you want with it, essentially. So you can have your driver program just exercise instances of those dinosaurs. So what we get is the theme of the dinosaurs. So now let's take a look and see how these dinosaurs are going to be created. So this is lecture number 3, for those of you who are following around with PowerPoints. And I'm going to go about halfway through, and then I'm going to start creating some dinosaurs for you. Because some people might want to start on this one. This is only an 8-week course, so we're going to be done before we even start. So, oops, I'm sorry, this is lecture number 4 I want. I never finished lecture number 3, that's why I had it out there, but I'll take a look at it, see if there's anything in there. This is lecture number 4, by the way. It's not number 3. I finished up to like maybe the last couple of slides of number 3. I'll eventually go back to that. So the concept, extending, not implementing, but extending. Implementing, you may have seen in source code examples, used for totally different purpose. It's for interfaces. Extension or extending is used for inheritance. And as common classic terminology is used in a couple of different languages as well. The concept of inheritance. You can create new classes that are built from existing classes. That's why you extend the class through a way of inheritance. You're reusing the existing class methods and fields, and you can add new stuff, new methods and new fields, and change the situation around completely. We have some terminology to think about: subclassing and superclassing. Anything above is super, or no, excuse me, yeah, everything below is sub. So get that right. Actually, I think about it upside down. I like to think I view inheritance upside down for some strange reason. Everybody else sees it the other way around, so I don't know. A subclass can be a superclass can be a subclass. It all depends on where it falls in the hierarchy. Anything above is super, everything below is sub. So you subclass, or you go back up to superclass, depending upon what you're doing. So subclasses and superclass have a is-a. This is the interesting thing, and it's kind of, yeah, I sort of have to take this for granted as well. New vocabulary word called is-a. So it's an is-a relationship, an object of a subclass is an object of the superclass. So every Tetrasaurus, and I'll just mispronounce and I'll just make up some words here, that's inherited from dinosaur is a dinosaur. So if you're a student and you're inherited from the person class, you're a person. So that's where the is-a comes into play. You're a student, but you're also a person. So you're everything that's in the hierarchy. Talk about it. So here's a superclass. The superclass is the person. See, this is what I see it upside down, because this is, you know, higher up, but it's lower in abstraction. What is a person? A person is nothing, but, you know, a student that extends a person has got more in it. That's why I see the scale flipped around, but I don't know. Anyway, so we started with person, and from person, we know, hopefully we're comfortable with this, but don't worry about any of the other code in here. Just take a look at this here, and we see public class person. We know it's a base class because we don't see this word extends in it. So we know this is a base class. So you might call them base classes. You might just call them classes. Any class is a base class, is a class, still a class. Over here we have a subclass, so it's below person. So person would be the superclass. We know it's a sub because student extends person. And this is this is all your inheritance right here. So we have public class student that extends person. So every student is also a person, and for the is-a relationship. So let's take a look at the contents of this. Make it a little bit bigger so I can kind of see both of them together, sort of. There we go. I sort of got both of them together. Should move it over a little bit. There we go. So person has a string name. Every person has a name, right? Does a student have a name? Yeah, gets it from person, because every student is also a person. So the name, actually, because we use this word extends, we're saying, okay, student, we're including everything that's in a person, we're also including the students. We're getting everything. So you don't want to put in here private string name over here. But does every person have a student number? No. Only students have student numbers because we added it right here. So as we go through the hierarchy and we start extending classes, we're supplementing, we're adding behavior to the class. It's not backward compatible, so, which is kind of weird. If you think about it, you know, software and everything's backward compatible. Not inheritance, it's not backward compatible. So public class student that extends person. Student has a name, but person doesn't have a student number. So, but we added it here. We don't have to add string, we string name, we automatically get it. We have a constructor, which is kind of interesting. So we have public person, which is what? Our default constructor. And we're setting name is equal to no name yet. Okay, so we know we haven't set a name yet for person. So we still have the same concept of the constructor. And then the constructor still has this name, same name as the class. But over here, you might notice something new. And I kind of mentioned this, I think maybe on Monday, the word super. All super says is the same thing that this does, but this is inside of the class. Super says go back up to my super class and run that constructor. So super is going to run person here. And it runs the one, because we didn't put anything in here, it's running the default constructor. If we put parameters in here, it would run the constructor that was associated with the parameters we gave it. It matches the footprint of the signature of the method call that we gave it. So super is going to say, so for every student that gets created, we're also going to get a person created, and when you do that, run this constructor here. So the name is going to be set to no name yet, unless we supply one. And then set the student number to equal to 0. We don't have to put student number over here because we don't have student number over here. We only have student number over here. And then we have another constructor, public student initial name. We're going to give it a name. And this is just word wrapped. It's the same as comma, integer, initial student number. I'm going to put a student number in there too. It's kind of a long word. I probably should shorten it so it makes it all fits on one line, but it's okay. Now you're wondering, going, well, okay, so student number is over here, but there's no student name. So what am I going to do now? Well, then that's why I'm writing super with the initial name. I'm passing the parameter from here that I took in when I created a student. Taking that parameter, I'm passing it to super, which means over here, the second constructor is going to work now. And the second constructor takes on string initial name, so it takes a name, and it puts it in there. And where does it get the name from? Well, it gives it from the command line that you created that instance from. So if I said new student name comma number, it takes the name, because now I'm using super with the name, sends it back to the superclass, runs this constructor now. So we have two constructors. Super with the name is running this one. Super with no name is running the default constructor. We're setting the name and we're setting the student number with this second one here. And we're taking it from the, when we created that instance of that object. Now we have get student number. Okay. Remember the setters and the getters? Alright, we have set student number. Setter, just simple setter and getter. Then over here we have get name and set name. I don't have to repeat these guys over here because I already have them. If I can use them, I can call them automatically from instances of student that I create. Are we good so far? That's inheritance. Now you know everything there's about inheritance, huh?
So it can do students dot get name.
I'm going to show it to you right now because until you actually see it, it's really hard to conceptualize it from a PowerPoint slide. So let's take temperature and play around with it. So hopefully we're familiar with temperature at this point. I'm going to close the driver program out. I'm actually going to close temperature out too. I'm going to create a new class because I'm going to inherit temperature. So I'm going to come in here, unless someone wants me to start in with a fresh one, I can start a fresh one, but the temperature is already built for us, so we can already do some stuff with that. So I'm going to go new class, and what am I going to call this guy? I'm going to call it advanced, no, extended. Oh, that's a long word. How about eTemp? Extended temperature? eTemp. That's short. Okay. So now I got eTemp here, and it looks just like temperature. It's just the name of the class I decided to call it. So it's not automatically going to decide for me that I'm going to use inheritance here. Instead, everything comes in as a base class, and then you decide that you're going to make it use inheritance. So the way I do that is I put here extends temperature. Automatically now I've turned this eTemp into a temperature class. So every eTemp that I have is also a temperature. So if I were at the driver program, I come back out to the driver program. I can now do this instead. I can go eTemp. I haven't really actually checked it. I'm creating a new eTemp. So, and I'll explain that in a few minutes why I have to change that. Because we're not backward compatible, which is interesting. Oh, I don't have a. Let's just do this. Let's just do this. So I have a new eTemp one. Well, I haven't set it. I don't have that in there either. Let's just go that way. Fix some errors here real quick. Here, let's get rid of this for a second. That's why I thought maybe I should start fresh, but let's do it this way. Here, you guys already have that code, right? So I can just start fresh. Actually, you know what? Let me just start fresh. I don't want to ruin this, just in case some student wants to see it. So I'm going to go like this and go. No, don't save changes. eTemp, it doesn't really matter. Let's just leave this alone. Start fresh. Start a fresh project. I'm safer with that. Otherwise, I start messing around with it, and then lo and behold, someone's gonna wanna see it. So I'll select Java project. This is gonna call this one. How about just create some dinosaurs? How about that? I'm going to call this one Project 2, JP-assignment 2. What did I call the first one? Okay, good. Assignment 2. There we go. Get organized here. All right. We'll just start building assignment 2. I'll use it. I can use a temperature theme. I can use a dinosaur theme. But this is what you're going to do, so maybe this is a good start because then we can finish this up next Wednesday as well. All right, so I'm going to close this guy. I have a habit of closing stuff that I'm not using just so I don't accidentally click in there and start modifying files and stuff because it closes all the tabs for you automatically as well. So now I'm safe. I'm not going to mess with anything else here. So I'm going to click on the source here. I'm going to add a new class, and we're going to make this the Dino class. So I'm going to type in Dino. Okay, and this is going to be the class that's going to represent a dinosaur for us because we're going to follow the theme of the dinosaur. So now I got class Dino, and in here I'm gonna give Dino a name. So I'll do a person. Actually, I'll do the person in the an extended class of Dino. So string name, and I'll make this private because I want to follow through with proper programming. And let's give him an age too. Private string. Oh, let's call it an integer. Integer age. So now Dino's got a name and an age that are private to Dino. Maybe inside of Dino. And let's give him some setters and some getters for the age. Or actually, let's give him a constructor. So I'm going to go Dino. No return type because we got a constructor here. And this is a default constructor because I didn't give him any parameters. And in here I'm going to say name is equal to no name. No name yet. And you can start typing this through here actually and use this as a base because I'm just going to continue this next because Monday's a holiday. So next Wednesday I'm going to finish this assignment for you. So I'll just continue work with this one. So if you're out there typing, just go ahead and type this. Age is going to be equal to, I'm just going to make him 21. Make him legal drinking age. Okay. So now we have the constructor. And we made a drinking dinosaur. We can make other constructors if we want. And actually, let's make another one. Let's just follow the example here. Dino, let's give him a string name so we can set his name. And in here, we're going to call this, because I want to make sure I run that constructor that sets the age to 21. And I left out my opening and closing brackets, so I'm going to put my opening and closing brackets in there. There we go. And then I'm going to set name. Oh, name. I don't like that. So I'm going to call it dname. Let's just do that. I'm going to say that name is equal to dname. All right. So now I have a constructor, and my constructor, so I can go out here and I can make a driver program. This is actually what I kind of recommend. Make the base class first, make the driver program, make an instance of the base class, make sure the base class works correctly. So I have to create it anyway, so I'm going to go out here and go new class, and I'm going to call this one main, because I like the word main better than driver. Finish. Or I can call it my dinosaurs or something. Here's main, and I can be, well, geez, now I have to go back here and cut and paste because I don't remember syntax. So I'm going to put a main method in there too. And I'm just going to steal it out of here, so I'm just going to go like this.
This checkbox you can do when you create a class.
I know, and I always forget because it's a brand new checkbox. There is a checkbox that will actually add, in fact, here we'll just do it that way so you see it. If you go new, I'll make another one, class, and I type in main. Public static, this is a new box actually. If you do this method subs would like to create, you can create a public static void main, so you can put it in there automatically for yourself. I already have a main, so let me call it my main. There we go. And then I go finish. What that just did for me was eliminated my need for cutting and pasting it, put it in here for me automatically. So, but I always forget to click that box for some reason. I know. So thank you for reminding me of that. So, I'm going to get rid of main now. And now you can see how to get rid of classes. So to get rid of, let me just close this back up so I don't accidentally edit anything in there. Now I have these two, so I'm just going to right mouse click and click delete. And there's a little box here. If you do this to a project, it'll ask you if you want to keep it in the workspace directory or if you just want to delete it completely. If you ever want to go back to it, you can delete it from Eclipse, but keep it in the workspace. If you want, here you don't get the choices for files themselves. So I'm just going to go OK to delete it. So now I have my main out here, and I got rid of that other one I didn't want to have. So out here I can say, and I can just go no Dino, my Dino, Dino1 is equal to new Dino, and we'll give him the name 1. There we go. You don't actually have to run all of the constructors. You know, you can just run one if you want. And if you don't get any error messages, sometimes you can, you know, we don't have any methods yet. So if we were back out here in Dino, I could fill in the body of this. I can say, you know, because we have to get our sets and our gets and stuff. And we should technically have a constructor that does everything. One that sets the name, one that says the age, one that sets the name and the age, if we wanted to do it that way. It's a lot of work. It's a lot of extra code you have to type for every class you create. So some people like me get sloppy, and I just put in whatever is needed, you know, and I leave out. And then later on, I can go back and put it in. So if I want to, I can get, you know, like, I don't know, string public. Let's just go public. Public. String get name. Yeah, I can say get name. And some opening and closing. Just go here, return. Return, and I can say name. You know, put the name. So then out here, I can actually put something in here that would, you know, it's like a system.out. Just for testing purposes, .print line. Because what you don't want to do is wait until you get to the end and then test it and go, oh, it doesn't work. So this is going to be, what did I call this guy? Dono. I don't like Dono, I like Dino. Dino1. So he's Dino1 dot get name. There we go. So now if I run this thing, and if I spell it correctly, and I run this thing, it should hopefully print out Dino's name, which is 1 on the bottom of my screen here. So I'm going to go ahead and compile and run it, and just make sure I'm at least starting out at the right point. So I'm going to say Java application, run. So now I see the word 1 out here. So now I know I have a working class. Doesn't do very much, but I got a working class. So let's extend the class and make a Tyrannosaurus or something. I'm just going to make a word up. So I'm going to go here, source, new, add a class, and I'm going to call this as a Tetrasaurus. I actually have to be able to spell it. I'll call it a tetra, because when I make new instances of it, I'm going to be trying to spell this thing. In here, I can add interfaces. I can automate it. I can put constructors with superclasses in here. I can do a bunch of stuff. Once you get the basic concept down, start experimenting with the switches. Because unless you understand what you're doing, whether you press the buttons at all, it doesn't really make. So I'm purposely not pressing any buttons or automating anything, so I can kind of show you what I'm doing. But you can actually provide the inheritance automatically through the class creation, just like we put that main method in there. But I'm going to do it manually, and instead I'm going to go here from Tetra, I'm going to say extends Dino. So now I have a Tetra. So if I made a new Tetra, I could run Dino's methods and I can have access to everything, because now I have a new Dino in my Tetra. So here I can put in, what's my Tetra going to have? A number of legs. So I'll have a private legs. What are legs going to be? Integers. Integer legs. So Tetra now has a couple legs in him. But he also has a name and he also has an age. So I can put in here, public get legs. And yeah, I have to put the type in here, huh? And I'm outside of the class as well. You're right. So that's why I don't like typing. I make mistakes. So And what have I missed here? I missed the opening and closing brackets here as well. There we go. So I can say public integer get legs. What's wrong with this? I'm sorry?
Return word.
Void.
Oh, return legs. Okay, and then, whoops, put a semicolon at the end. Thank you. I did it myself. But before I do that, I'm going to make another constructor. I'm going to call it tetra. So the constructor name for tetra is going to be, it's going to get the name, let's say. So I get string n. And we'll also set in with the number of legs, so you can sort of see what happens here. So I'll put here an integer L for legs. That's going to come in. And this is the constructor for the tetra class. So when I make a tetra, this constructor is going to run. And he's also going to set, so I'm going to go super on this. This is what we had in the PowerPoint a few minutes ago. I don't have in tetra, let me actually just do this so I don't get any errors here. In the tetra class that I created, I don't have a name, but I'm going to take a name. I want to create a dinosaur with a name and a number of legs. So I put in here the parameter that's going to match something in Dino, and hopefully I think I did that with name. So I can go here and say string n. And if I'm doing that, if I'm spelling it correctly actually, I'm going to take from, pass n to it, I'm going to take n, I don't have to put string in there. If I can take the string name that came through from the instance creation from the driver program, and I'll show you how to do that in a second or so. I'm passing it back to super, and super is going to take this and give me a constructor that matches this, and I have one here, I hope. Dino string dname. That's going to essentially set the name for me. It's also actually going to set the age to 21. But it's going to take the name coming through here and set it to name. So if I get name from my tetra, it should give me the name that I've given the tetra when I've created the instance, if that makes any sense. So out here I can say, legs is equal to L, because I have L coming in here as well. So let's make some instances of some tetras and some dinos so you can sort of see. And then I think what I'll do is I'll stop at that point, because this is going to be information overload for anyone who's brand new to this. So I'm going to make sure I save it. I'm going to save it by closing it actually. There we go. Out here, maybe I should have left it open, who knows. So out here, this is Dino, let's see, close Dino. Okay, now we're in main. So instead of just creating a Dino now, and we've run Dino, and I've run the method to get name. Now I'm going to show you what inheritance is all about. So I want to create a tetra. So I'm going to say tetra. It's going to be tetra 1. Let's go just use the same naming convention. Is it going to be equal to a new tetra? And I have to have a constructor in there, and I do have a constructor that matches whatever I give it here. So if I go like this and I don't have a default constructor, oops, if I put the word new in here as well, do I have a default? I don't think I have a default constructor actually in Tetra, do I? Let's see. Nope, did not create one, so I can't run one because it doesn't exist. Although I have a default constructor in Dino. This is the problem I was actually having when I started messing around with the temperature, because I don't know if I had I don't know what was going on. My inherited class didn't have a default constructor, so when I changed the names around, I was trying to do that. But I do have a constructor that takes on the name, so I can put in here Bob. And what does he have? The number of legs? 4. So now I can make a Tetra 1 that has the name Bob with the number of legs 4. Bob will come through here into the Tetra class right here. This is the constructor that we're running, and we don't have name in here, but we're supering n, which is the name variable that's coming through as the parameter, and it's coming back to Dino. Let me open up Dino again. Dino's got one. Dino's got name in here, and Dino's got a constructor that matches the string name. right here, dname. So dname is going to be set. So if I wanted to do get age, let's do get age because we're going to see that his age is going to be set to 21. So if I go, did you have a question? Okay, I thought I heard someone crying for help. Get age. This isn't that bad once you get familiar with the concept. I know it's information overload for some. Return age. Okay, there we go. So now I just added. Did I spell it correctly? Nope, I left out an I. Public. Yeah, there we go. We got, what do we got here? Public get age. I got public get name. If I go back to the main program here, each tetra's got everything that a Dino has. So I should be able to run get name, get age from tetra. I don't have to reinvent the wheel. I can run because every Dino is a tetra. I can also do what's called casting, upcasting and downcasting. And I'm going to show you this now, and then you're going to wonder why in the world am I showing this to you. Because further down the road, you're going to take objects and you want to cast them into their other object types for certain reasons. Why? Because we have strongly typed language, so we compare integers with integers, object types with object types. And if I'm going to compare a Dino and a tetra together, I need to turn one of the Dinos into a tetra, or vice versa. So I'm comparing apples with apples. So the object is called upcasting, because we're taking it from the lower sub and we're putting it back up into the super. So if I wanted to, I could do this. I can say Dino 2, let's call him 2. And you're wondering, well, what does that do? Well, it actually makes an object without an assignment. And the object name, because this is the other thing I didn't show you yet. When you create an object, I've been doing it this way. I've been saying Dino with a name is equal to new Dino, running a constructor this way. This is an object reference to an object called 2 without an assignment. It's just a Dino. It doesn't have anything. So I could do this in 2 steps. I can say 2 is equal to, and then I go like this, and I go Dino. And then I say tetra 1. Yep. No, actually I took tetra 1 that already existed, and I typecast them. I can also do this. This might actually, here, let me not overwhelm you completely. I can do this as well, and that works. What I've done is, this is what's called the cast. I've taken a tetra 1 and turned him into a Dino and assigned him to a Dino reference object. I know, it's going to be overkill, but you'll get it eventually if you don't get it. What I can also do here is do this. I can say, well, I have Dino 1 here, and I can say, you know, the exact opposite actually. I can take a tetra. I can't take a tetra. I can't take a Dino and turn him into a tetra, because that's not up, that's down. So Dino doesn't have any of the tetra characteristics, but a tetra has Dino. So if you think of the hierarchy and start imagining what's going on here, I got the base classes, and we're not backward compatible, so we can go forward. And so when we upcast, we actually go down the hierarchy back to the bases. And everything inside of the higher classes is inside of, the lower classes are all inside of the higher classes. That's why I say I see it upside down. Because I always think, you know, like the base is part of the super, but then how come I'm upcasting when I go down back to the base? It's because you're going super, so you're going back up the hierarchy.
Downcasting doesn't work?
Downcasting doesn't work.
Okay, so
Because
no such thing then.
there's no such thing as it. So you can only take a person and turn him in, you can only take a student and turn him into a person, or a tetra and turn him into a Dino, because tetras are Dinos. Because it's not really a cast, it's not like taking, so traditional casting is called typecasting. And you're taking a float and you're turning it into a double, because you need to add it together with another double or something. And you're doing a data conversion. And what ends up happening is it's not very safe, because if you take a big number and convert it to a small one, you're going to lose precision. Or, you know, it works okay if you take a little number and turn it into a big one. It's actually the exact opposite theory with objects, because you can take a big object and turn them into a little one, no problem. You just cut away the rest of the stuff and you put them back to the base. But you can't take a little object and turn them into a big one. which is weird thinking. So those people who are familiar with casting have a hard time visualizing this. Or, I don't know, but this is not coming for another week or so. But I thought I would show it to you because I don't know why I thought about it. Oh, this is a great opportunity. Let me go back, reduce the abstraction here a little bit, and go back down to something a little easier for you. Let's get rid of this. But that's just like an introduction to casting. We can also do the same thing with other types because everything is an object. We can take a string and make an integer into a string the same way if we wanted to. So if we said, as an example, and I'll just finish this with this example, integer I is equal to 10, and then I had string x, for example, I could say x is equal to, and then I go here, string I. And that works if I spelt it right. Well, string I, well, all right, theoretically, string equals string 15. Well, I probably have, anyway, long story short, you can take, don't use that as an example, I'll come up with a better one. You can take numbers and do the same thing with them. As long as, well, my problem is I used an integer, which is not a, it's not a string, it's not an object. A string is an object, integer is not. So that's not going to work. I tried to typecast with an object, or object cast with a type instead of an object. But you have to have two objects. If the two objects are compatible, you can translate one object into the other object for comparison reasons, for formulas, for parameters to functions. There's all sorts of different things that you might use that for. Just put it in the back of your mind, save it for later. Let's not worry about it right now. So now I created an instance of this object, and I called it tetra1, and it's equal to a new tetra. It's Bob. So I could print out if I wanted to, system.out.println. And now I'm going to say tetra1.getName. And then people are going to be wondering, well, we don't have a getName in Tetra1. We do. Everything that's inside of Dino is now inside of Tetra. So Dino, if we have a method inside of Dino and Tetra is extended from Dino, we have it inside of Tetra, even though we don't have it in here. We just have getLegs in here. So we can run methods, public methods. We can run anything we want, as long as it's public. If we're serious about our integrity, we don't make it so that the variables, the data is public. We make that private still, because this private data, Dino is the only one, because these guys are private, Dino is the only one that can manipulate string and age. And he's doing it through the constructor and through the methods, get, sets, and stuff like that. And then Tetra is the only one who can manipulate legs. Dino can't manipulate legs, he doesn't know about it. But Tetra can. And then if we had another one, let's just do another one here. So let's say we want to go a little further in the hierarchy. So I'm going to go new, class. And for your assignment, you don't actually have to go higher than one level. But we can extend from extension. So example here, we're going to call it Ultra T. Let's do Ultra Tetra, bigger Tetra. And Ultra Tetra, over here, he's going to extend Tetra. So now we have an Ultra Tetra, Alta Tetra. Alta, is something wrong with that word? Tetra. Let's see what the error message says. Implicit superconstructor Tetra is undefined. Yes, I know. For default constructor. Well, let's forget about that error for a second, because I need to, there's a requirement that I need in order to do this. I need to actually put a default constructor in here. So if I do that, Tetra here needs a constructor. So we'll put a constructor in here. We'll make it happy. Okie dokie. Now we can go back to Ultra Tetra, and Ultra Tetra error message went away. Why did they do that? Because the problem with inheritance is that every new object that gets created contains an instance of the previous object that it extends from. And what I just did a few minutes ago is I made a class Ultra Tetra, that also makes a copy of Tetra, but there's no default constructor, which means it can't construct one if it wanted to. So the requirement is you have to put a default constructor, whether you're going to use it or not. In this particular case, I left it empty. I didn't use it. And then that's actually kind of a good thing I forgot to tell you about. But not a bad idea to put a default constructor. A lot of people do it this way. If they're going to leave it blank, they'll put it all in one line. Maybe like that with it. Why are you going to do that? Because your compiler is going to give you an error message if you don't do that. Because technically you should fill it in and you should like have the default behavior. Because, you know, like for example, this one should probably say legs is equal to 0. You know, if I wanted to be legitimate with this. Because when I create an alter tetra, it's going to try and create a tetra. Because every alter tetra will create a tetra. But it can't create a tetra because I don't have a constructor that does it. So it's going to, it's impossible to have one.
Is it even better if we go create a super?
Yeah. Well, when I start filling this out, this is kind of information overload for tonight, but next lecture, what I'll do is do it properly for you. And we'll have supers going all the way through the line with thises going from all the constructors, and we'll try to build this up. Because there really is not very much to that assignment outside of building the subclasses. So, any questions? So now you can actually build the base for assignment number 2. Actually, you could take this. This is assignment number 2. Build Dino, fill in the behavior for Dino, get all of his setters and getters in there. Technically, the assignment doesn't require, for those of you who were here in the beginning, I went over the assignment, it doesn't require you to do anything. It just says create a Dino. It gives you, but if you want, you can actually go through the process, create all the constructors, create the setters and the getters, do it properly, and then create some tetras. Actually, the assignment has you create 3 classes all at the same level. But I'm going to do a little bit more for you, because next time I'm going to extend from the extension, and then I'm going to show you how the constructors fire. So if you build the bases, you can do the same thing. You can extend from the extending, and then you can see the constructor firing order, and which is kind of interesting actually. And then you can kind of see all the pieces come together, and that's pretty much the basis of inheritance when you think about it. So if we don't have any questions, we are done with the and I'm on time. We're done with the object-oriented programming course for today. Monday is a holiday; it's Memorial Day, so there's no class. But we are like ahead of schedule at this point, so we're doing good. So I'll see you next Wednesday for class at 5. So, all right, take a 5-minute break before we start the next one. Perfect.